Hello everyone, it's me Namrata Shrestha explaining the mapping and visualization project that I completed by preparing an interactive WebGIS map with GeoJSON and API integration. Let me open VS Code where I have written entire code. This code creates an interactive web-based mapping application using the leaflet JavaScript library for mapping and additional tools like GeoJSON and API for data integration. The code starts with the standard HTML structure, the doctype HTML that declares the document type, and the HTML element wraps all the content. The head section contains metadata, styles, and script necessary for the map functionality. External libraries like Leaflet for map and Axios for fetching data are linked here. The body contains the main content, including a map container and the script that powers the functionality. Here, the map is initialized by creating a map view. The center of the map is set to Kathmandu with its uh, longitude and latitude provided, along with a zoom level of 7 regional scale. Then, two different base layers are added as map layers. They are OpenStreetMap layer and satellite view layer. Here the different functions are given to style the GeoJSON layer uh, by providing different color, weight, and opacity to provide clear and insightful visualization. GeoJSON data are loaded where GeoJSON is a format for encoding geographic data structure. The map displays multiple layers like student, province, district, municipality, and school that are all represented as GeoJSON. Here, the data is fetched dynamically using accessor.get and styled with specific functions. Let me provide an example of province layer. Here it fetches Nepal state GeoJSON. Each feature province is styled in green as mentioned above and annotated with a pop-up showing the province name and province code. Similarly, the other GeoJSON of district and municipality are added. The weather layer displays current weather condition for districts. It fetches data from Open Weather Map API using the district central coordinates, latitude and longitude. It makes an API call accessor.get and adds marker to the map with weather icon, this one, and detailed pop-up information like location, temperature, condition, and wind speed. Similarly, the other layer, air quality index, adds air quality marker to district. It fetches AQI data from the same API open weather map for location showing pollution levels like PM 2.5, PM 10, and so on with pop up details. The other school layer is added, which contains GeoJSON of the schools that are available um, 5 kilometer far from around 5 kilometer from my location. It displays school's location using a GeoJSON file. Here, each school is shown with a specific icon. This one, and this pop-up give detailing of the school available. Then a layer control is set up that allows toggling between base layers and overlay layers. Here the base layers are OpenStreetMap and satellite view. Similarly, the overlay layers are students, provinces, districts, municipalities, weather, AQI, and school. Map interaction enhancement are uh, gained by scale control, layer control, and pop-ups. The provided custom icons are useful for weather, AQI, and schools to make data visually appealing and easier to understand. This entire stepwise breakdown covers the essential parts of this application. Now let me run this code. Here we can see the heading of the map, interactive WebGIS map with GeoJSON and API integration. Here we can see zoom in and zoom out along with the scale. In the layer, we can see here the base layers, OpenStreetMap, satellite view, and similarly the other overlay layers. When clicked on the student, we can see the properties of the student, that is name, municipality, district, province, along with latitude and longitude. In province, we can see the province number along with the province code. In district layer, we can see district name, length, and its area. In municipalities, we can see the name of the municipality, its level, and on which district it is located. The label may be either Nagarpalika, Gaonpalika. Similarly, we can view the API. The weather API contains location, temperature, condition, and wind speed. The other API, air quality index, contains the AQI level along with PM levels. The AQI level can be either fair or very poor. Similarly, you can view here the school that are present 5 kilometer away from my location. This is my location, and these are the schools that are present around my location within a distance of 5 kilometer. Here we can view the properties of a school, that is either name, amenity, address street, ID. Um, I have included all this information in my LinkedIn account as an article, um, where this is the front page along with the title. This is the abstract where I have included what is the project about, how it is done, and how it is useful for the user. The introduction contains the importance of WebGIS along with other multiple extensions, layers, overlays, APIs, and proximity. The objective of this project is to develop skill in geospatial data collection and analysis, and also to gain experience with GeoJSON, OpenStreet, and API integration. The other objective of this project is to create interactive maps with dynamic overlays and perform spatial analysis such as school proximity evaluation by using overpass turbo. The entire process included is data collection, where I have collected data of my classmate, including myself, in CSV format as this. Then GeoJSON was created by using QGIS. Then two different base maps were included. One is OpenStreetMap and the other is satellite view. Then the other necessary layers were overlaid. They are administrative boundaries. The administrative boundaries were get from this link, where I have got the GeoJSON of province boundary, district boundary, and municipality boundary. The other overlay layers with API, that were weather and air quality index. Weather aims to visualize real-time weather data for district centers in Nepal, whereas air quality index focuses on fetching and displaying real-time air quality index for various district centers of Nepal in the web map. Along with these two APIs, the GeoJSON data with student location was also overlaid in this way, where we can view the uh, properties like name, municipality, district, province, along with latitude and longitude. Extra layers with labels were added in this way, where we can see the base layers and the overlaid layers. Skill proximity analysis was done by using overpass turbo, where it was used to query all schools within a 5 kilometer buffer of my location. This is the code used when run. I got the GeoJSON, which was exported and added to the code, which we can see in the map in this way, where we can see the school name, uh, ID, address, amenity, name, in English as well as Nepali, along with operator type. The technical highlights of this project are dynamic layer management, efficient resource loading, along with enhanced visualization. The tools and technologies used are leaflet, mm, uh, a, a library of JavaScript for interactive map creation and displays, uh, with open weather map for retrieving real-time weather, and AQI for specific location, GeoJSON for spatial data representation. Proximity analysis was done using Overpass Turbo. JavaScript enhancements like XSO was used for API requests to get cleaner and more readable code. Similarly, the other geospatial tools like QGIS was used to convert data into GeoJSON format. This project was conducted successfully to demonstrate the integration of geospatial data, real-time API services, and interactive web mapping technologies to create an engaging and informative WebGIS map. By visualizing administrative boundaries, student location, weather condition, air quality indices, and school proximity, the map serves as a versatile tool for spatial analysis. The use of dynamic layers, efficient resources loading, and custom visualization enhances user interaction and accessibility. Thank you.